Assalamu alaikum everyone. This is Shakil and today I'm going to tell you something about physical quantities and units. That is unit number 1 of AS Physics with the subject code of 9702. Okay, so let's start with the proceedings. First of all, let me tell you about Unit 1. The Unit 1 is physical quantities and units, and it comprises of 4 subsections. The first section in it is physical quantities, in which we're going to study about physical quantities, and then we are going to study about the estimations. Number 2 is SI units. Every quantity is having SI unit, so we have to see how many units are there for SI for the base quantities and for the derived quantities, and what is relation between them. Similarly, we're going to look for the prefixes in this section. Section 3 is errors and uncertainties. This is a very important topic, as this is the only topic that is going to be used in all the 5 papers in A levels. So we'll study about the errors while taking the measurement, and the uncertainties and how to express them. This is actually the core topic. 1.3 is the core topic of chapter 1. And the last section is 1.4, which is scalars and vectors. We're going to study about the difference between scalars and vectors. And mainly this section would be dealing addition of the vectors. So that would be a bit challenging as well. And this is also important because vector concept is going to be used at many places and in many chapters, both in AS and in A2. So what I've decided is we're going to study these 4 topics through 4 video lectures. So today we're going to start with the first video lecture. So we're going to discuss about physical quantities consisting of numerical magnitude and unit, and then we're going to study about reasonable estimate of physical quantities. Okay, so first of all, we have to see we have to understand that all physical quantities consist of numerical magnitude and unit. So this is a concept that we have to recall. Actually, all of you are very well aware of it. You must have studied it in IGCSE or GCE or DEXL or MYP or metric about the physical quantities. So the quantities which can easily be measured using an appropriate measuring instrument are known as physical quantity. The word physical means that you can measure that, you can sense that quantity. And then in order to represent the physical quantities, we use a magnitude. You know, magnitude is a number, a numeric number, size, and it is having the unit, and sometimes it is having the direction as well. And you know, that is in vectors. So there are a few examples. Let's say the mass is 10 kg. 10 is the magnitude and kg is the unit. Similarly, weight. Weight is 20, which is magnitude, newton, which is unit, downwards, that is the direction. As I told you, some quantities need direction as well. Speed is 20 meter per second. Velocity is 20 kilometer per hour to east. So all of these quantities, along with many other quantities, are known as physical quantities because we can express them with a suitable number and a unit. Now let's move on to the most important thing for today, that is estimation of the physical quantities. So what is meant by estimation? Estimation is actually the prediction. It is actually the prediction of the magnitude of a physical quantity without using any measuring instrument. So that is like the estimation, like you don't have any measuring instrument with you and you are going to tell about the magnitude of a physical quantity, and that will be based on your previous experience. Okay, so there are 2 types of such estimation. The first one is direct estimation, which depends upon your knowledge or experience. And second is calculation plus prediction based, like you'll be predicting some values and you'll be using them in a formula to calculate the value. So let's talk about some of the estimations. Generally, we have to talk about all the estimations like the mass, speed, temperature, pressure, force, then about electromagnetic waves, their speed, their frequency, their wavelength, about the resistance of different things, and many other things are also there. So let's start with the mass. So I have written some masses. Let's say, what's the mass of a CAIE student? CAIE student, is like between the age of 14 years to 18 years. So the mass, average mass is 50 to 70 kg. Remember one thing, in estimations, you are allowed to give answer in a range. If some student is writing that the mass of a CIE student is 50 kg, someone is writing 55, someone is writing 60, 65, 70, everyone will be considered as correct. So all the answers of the estimations are actually in a range, but you can't go beyond that range actually, because this is average. This is not for the one. Okay, so athlete mass is between 55 to 80 kg. Apple mass of one apple, it is between 100 and 200 gram. Then 50 centimeter ruler mass, plastic ruler that fits into your geometry, that is 10 to 20 gram. And a family car with mass is between 800 kg to 1200 kilogram. Okay, and one more thing, they in this type of questions coming in the exam from this topic, that would be either the MCQ base, or even if they're coming in the theory, they will be asking you to tell the value. So you don't have to write sentences about it. You just have to predict the value. Okay, the next one is time. Okay, so time for light to reach Earth from the sun. I remember once my science teacher in grade 7 or 6, I guess, told me that light takes 8 minutes. The first light ray starting its journey from the sun surface take almost 8 minutes or 480 seconds, around about 500 seconds to reach Earth's surface. So, we can use that time along with speed of light, which is 3 into 10 to the 8 meter per second, to know the distance between sun and Earth. Then the next one is winner of 100-meter race. So if you're fond of looking at the race, whether that is Olympics or the Asian Games or the European Games or the American Games or like any other Commonwealth Games, you know that the 100-meter race, the athletes are completing in between 10 seconds and 12 seconds. And the world record is of Usain Bolt, and that is 9.58 seconds. Let's move on to the next one, that is speed. Speed, rate of change of distance. So speed, some common speed of sound in air is 300 to 330 meter per second. It means right now you are watching the video and you are hearing my sound. So the sound is emitting from the loudspeaker of your device, whether it is a mobile phone or a tab or a laptop. When it is coming out of the speaker, it is going into air, and it is traveling outward and reaching your ear with a speed of around 330 meter per second. And the range depends upon the temperature actually. Then the speed of sound in the liquid, that is around 1500 meter per second, because the particles are very close to each other, so sound travel faster. Then speed of sound in solid is 4500 meter per second, because the atoms are more closer, so the speed increases. And then the light speed is 3 into 10 to the power 8. That is the fastest in nature. You can also express that as 300,000 kilometer per second. The other common speed of car on highway, it's around 100 to 120 kilometer per hour. Speed of a bus on highway or expressway is between 80 to 100 kilometer per hour. Okay, now we have to solve a question that is related to equation and prediction base. Let's say, what is the speed of a 100-meter race winner? What is the speed of winner of 100-meter race? So we have to find the speed. So you'll say, okay, no problem, we can find that because we know the formula, V is d by t, and we know that the distance is 100 meter. Now for the time, we don't know, so we have to predict it. So we predicted the time as around 12 seconds, because the world record, all the good runners, athletes, take almost like between 10 to 12 seconds. So I'm using 12. So 100 over 12 is 8.3 meter per second, right? So The answers are acceptable within range. So for time, you can also write some other values. Like over here, you can write 10 seconds or you can write 11 seconds as well. So now moving on to next, some random quantities. So the first one is temperature of hot oven, that is from 250 to 400 degrees Celsius, in which your favorite pizza is going to be cooked. So the human body temperature is 37 degrees Celsius. The air pressure or the atmospheric pressure is 1 atm or 100 kilopascal. And air density is 1 kilogram per meter cube. You have to memorize all these numbers, unfortunately. Okay, so the water density is 1000 kilogram per meter cube. The next thing is pressure due to 10 meter of water. You know, when things go into the water, then water also or liquid also exerts pressure on them. So that is known as liquid pressure. So we know liquid pressure is rho GH. So rho is the density of water, which is 1000. G is the gravity, which is 10, and height is 10. So we say it is 100,000 Pascal, 100 kPa or 1 atm. So we can say that the pressure due to 10-meter depth of water is actually equal to value of atmospheric pressure that is right now exerting on yourself and myself as well. So what should be the total pressure at the depth of 10 meter? 1 atmosphere is due to the air, which is acting on the water. And then the next atmospheric pressure is due to 10-meter depth of the water. So total of 2 atmospheric pressure, 2 atm pressure is exerting on an object which is immersed in the water at a depth of 10 meter. Okay, let's move forward now to kinetic energy. Okay, so you know kinetic energy is half mv square. So if we want to tell, this is actually the prediction and equation based estimations. So you need to tell the kinetic energy of a car on highway. So you'll say, okay, we know the formula and we have to estimate the mass as 1000 and we estimate the speed as 30 meter per second. So this speed you have to actually predict, because you know the speed is around 80 kilometer per hour or 90 or 100 kilometer per hour, and you will be converting that into meter per second. So this is like 450,000 joule or 450 kilojoule or 0.45 megajoule. The answer is like in a range. Maybe in MCQ, the answer is 5 megajoule or 4 megajoule or 3.5 megajoule. So you have to choose that. So you always have to choose the closest answer from the MCQ options. Kinetic energy of bus on the expressway, same formula, but this time mass of the bus is more than car. It is 5,000 and the speed is less than that of car, around 28. So it is 1960 kilojoule. Then kinetic energy of athlete in 100-meter race. So you know it is half mv squared. Mass of athlete is around 75 and speed is around 8 meter per second. How speed is it? You know that the winner is almost taking like 10 seconds to cover 100 meters, so the 10 meter per second, but this speed is rare. Not every athlete is having this speed. So we say that the normal athletes which are coming at the last, actually they are traveling with less speed than 10 meter per second. So it can be 9, 8, 7. So I am using 8. So you can just multiply them to get the kinetic energy of the athlete. Let's move forward to waves now. So speed of sound is 300 to 30 meter per second in air. Speed of electromagnetic waves or light is actually the fastest in nature, 3 into 10 power 8. And then there are 7 electromagnetic waves. And for that, you can memorize them through this sentence, which is read my inner values using X-ray glasses. R for read and R for radio. M for my and M for microwaves. I for inner and I for infrared, V for values and V for visible, U for using, U for ultraviolet, X-rays, and G for glasses and G for gamma rays. So you can make their order as read my inner values using X-ray glasses. So radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma rays. So what you have to do is you have to predict the values of the wavelength, because the speed is same for all the electromagnetic waves. So all these waves are having the speed of 3 into 10 to the power 8. but their wavelength and frequency are different. So you have to memorize this wavelength. For radio waves, okay, let's say for radio wave, it is between 10 per minus 1 meter to 10 per 3 meter. For micro, it is between 10 per minus 2 to 10 per minus 4. For infrared, it is 10 power minus 4 to 10 power minus 6. For visible, it is 10 power negative 7. For ultraviolet, it is 10 power negative 7 to 10 power negative 9. For X-rays, it is from minus 9 to minus 12. And gamma rays are having the least wavelength, that is ranging from minus 11 to minus 13. So you need to memorize all these values of the wavelength. Okay, you know the speed is constant for all these waves from radio to gamma rays have same speed. So their wavelength and frequencies are different. So if you know the wavelength, you can easily find frequency. How? By using this formula, V equal F lambda. From here, F is V by lambda, and you know V is 3 into 10 power 8, and lambda is the one that you have to choose, that you have to memorize. Let's say I'm talking about X-rays. So X-ray range is around like from minus 9 to minus 12 or minus 8 to minus 12. So I'm picking up number of 10 per minus 8. So this is, let's say, the wavelength, and this is the speed. So when you solve it, your answer is 3 into 10 to the power 16 hertz. So that is the frequency of X-rays. So you have to memorize the wavelengths, and speed is same for all the waves. So you can easily find frequency by using the formula F equal V by lambda. Okay, the next thing over here is actually the electricity section. So in electricity section, we have to look for the power and resistance values. So the domestic lamp power nowadays for the LEDs are usually from 12 to 30 watt, and the voltage for domestic use is 220 or 240, and we have to find the resistance of a filament lamp, and this is like an estimation plus equation. So what equation we will be using? You know that we have the voltage value of 220 and the power of a domestic lamp, let's say filament lamp is 60 watt. So we have a formula P equals V squared by R, and then you have to find R, voltage and power values are given. So simply filling the values, you will get the resistance as 806. Your answer can be from 800 to 1000 ohm. So you know you can use any of these formulas of the power to find the power value as well. So the domestic lamp of the filament lamp is having a resistance of around 800 ohm. Okay, next thing is nuclear physics estimation. So the first thing that comes in nuclear physics is actually the atom. You know, everything is made up of atom. So atom consists of nucleus, like this is the nucleus. So what prediction we have to do? The first prediction is the diameter. How much is the diameter or thickness of a nucleus? How much is the diameter of the atom, right? This is the thing. So the nucleus diameter range is from 10 to the power minus 14 meter to 10 to the power minus 15 meter. That is too small. 10 to the power minus 14 meter is for heavier atoms like uranium and iron and plutonium and iridium, and 10 to the power minus 15 is for lighter atoms like hydrogen, helium, lithium. So this is for them. Now the atomic diameter range is 10 to the power minus 10 to 10 to the power minus 11 meter, and similarly 10 to the power minus 10 is for heavier atoms and 10 to the power minus 11 is for lighter atoms. So you need to memorize these values. Now, the next thing is density or volume of the nucleus or atom. So you have to estimate that. What is the density of nucleus or density of atom or volume of nucleus or volume of atom? So this is actually estimation plus equation. So for example, iron is an element and it is having a nucleon number or mass number of 56. So 56 is the atomic mass number or the nucleon number. Now, everyone knows that all the nucleuses or atoms are spheres actually, and you know the volume of sphere is 4 by 3 pi r cube. So what you'll do is you'll simply put the values. This is pi, and r is like the radius, and you know that iron is among heavy nucleus, and for that we have the diameter of around 10 to the power minus 14. So 1 into 10 to the power minus 14 divided by 2, because you know radius is diameter over 2, and then you have to take cube. So this is the volume. So this is actually the volume, 5.3 into 10 to the power minus 43. Okay. Next thing is if you want to find the density, you know, density is mass or volume. So as the iron is having an atomic mass of 56 U, this is actually the unit, atomic mass unit or U. We don't write that in kilogram. And the volume is already calculated. So like that's how we calculated its volume, 4 by 3 pi r cube. And you know, this time we have to take the diameter of the atom, which is 1 into 10 to the power minus 10, the whole atom. Okay, so the density comes out to be 1.1 into 10 to the power 44 U per meter cube, where 1 U is actually mass of 1 nucleon, like mass of 1 proton, mass of 1 neutron. That is 1.66 into 10 to the power minus 27, and that will be provided in the data sheet. So mass of 1 proton is equal to mass of 1 neutron, which is 1 U, and mass of 1 nucleon is 1 U, which is equal to 1.66 into 10 to the power minus 7 kg. Now we are almost done with that. So let's solve a problem. If you want to solve it yourself, so you can just pause the video and solve it, and then you can look for the answer or listen how I'm going to solve it. Find approximate masses in the following. The first one is air in a container, and the dimensions are 2 meter by 1.5 meter by 3 meter, like length, width, and height. So at standard pressure, you have to tell how much is the mass of air in that cylinder. So what we'll do is we have to measure mass. So we'll say, okay, density is mass over volume, and mass is density into volume. So density is actually the estimation, which is 1. Like the mass, like the density of air is 1 kilogram per meter cube, and volume, for volume, we'll be using the equation because dimensions are given. So it is cuboid, so length into width height. So you will get the mass as 9 kgs. In that cylinder of dimension 2 meter by 1.5 meter by 3 meter, 9 kilogram of air is filled over there. The next question is related to liquid. Your water is in cylinder of diameter 50 centimeter and height is 1.25 centimeter. So there is a cylinder with the 50 centimeter diameter and height of 1.25 meter. You have to tell how much is the mass of liquid or water in that cylinder. Again, we have to use the equation density is mass over volume and mass is density into volume. So density is your estimation and volume you can measure by using the equation. So volume, you know, it is a cylinder, so it is pi r square h. Density is 1000, so 1000 into pi r square h. So r is like 0.5 meter or is the diameter, and radius is like 0.25, and then height is 1.25. So you'll get the answer of 245 kilograms. Okay, so now we're done with that. We're done with the estimation. So what I'll do is I will share a worksheet with you and I will solve that worksheet as well. I'll make a video solution of that and I'll share that worksheet as well. So now we have to move on to the next topic, which is very important. It is significant figures, a very short topic, and it's important in the practical exam as well and in theory exam as well. So what are significant figures? Significant figures are actually the decimal number from 0 to 9 that are considered to be representing amount of a measured or calculated quantity. So these are known as significant figures. So there are certain rules to determine the significant figure. First rule is that all non-zero numbers are always significant. Like from 1 to 9, they are always significant. The second one is 0, which is actually a troublemaker. So 0 sometime is significant and sometime it is not significant. So when 0 is between two non-zero numbers, it is significant. When 0 is between two numbers with a decimal, it is significant. And when zeros are at the end with a decimal and a non-zero number behind them, then those zeros are also significant. So that's why this is having 3 sig fig, 3 sig fig, and 3 sig fig. Now we have to look for the situation in which 0 is non-significant. So when the trailing zeros are there, trailing zeros are the one which are at the end of a number without any decimal behind them. The trailing zeros are not significant. Then the leading zeros, which are not having any non-zero number behind them, they are also non-significant. So all of these numbers which are written in number 3, they are in them only one significant figure is there. The next thing is, what are the rules to write the calculated value in appropriate significant figure? This question is important in theory paper. Like, let's say the distance is 20.50 meters. So this is 4 sig fig. All the zeros are significant, and time is 20. So in time, only one significant figure is there. This zero is not significant. If you don't understand, just go back in the video 30 to 40 seconds behind, and then just rewind the video, and you can see about the rules for the zero as being significant or not. What you have to do is you have to find speed in meter per second and express your answer in appropriate significant figure. So we're going to find speed using formula distance over time. Distance is having 4 sig fig and time is having 1 sig fig. So your answer is 1025 meter per second. Now, like the value of the distance, which was 20.50, this is having, if we just look at 2050, it is having 3 sig fig because this zero is not significant. And if you look at 20.50, then all the zeros are significant. So 4 sig fig are there. So in the raw data, which is D is having 4 sig fig and time is having 1 sig fig. So the rule is the answer in calculated value must be having significant figure as the least significant figure in the raw data or one more than least. So it means that you have to write the same significant figure in your answer as the least significant figure in your raw data, or you can write one more than least. So least is 1, so you have to express your answer in 1 sig fig or in 2 sig fig. So in 1 sig fig, you can round off this value to 1000, and in 2 sig fig, you can write that to 1030 as well, because this 1030 is actually having 3 significant figures. But the thing is, actually, you can't write, like you have to write in 1 or 2. So this is like 3 sig fig, so you can't write that. And then your rounded off answer is considered as 1000 meter per second. So you will write that answer. Because if you want to write in 2 sig fig, so you have to write in 1100. So that would be too much rounding off. So that's why it's better to write your answer in 1 significant figure. Okay, the next thing is you have to find momentum of the car. Mass of the car is 1250. 0 is not significant, so it is having 3 significant figure. And then its speed is like 1025, which is having like 4 sig fig. So it is 1281250. Of course, it's like 7 significant figures are there. But as in your raw data, mass is having 3 and velocity is having 4. So you have to write least significant figure, which are 3. So you rounded off your answer to 3 sig fig. That is 1.28 into 10 to the power 6 meter per second. So that is 3 significant figure answer. Okay. Next, move on to another example. Let's say initial speed is 10 meter per second, final is 20.5, and time is 2 seconds, and mass of the moving object is 2.50. So now see how many sig figs are there. This 0 is not significant, so this is having 1. This 0 is significant, so this is 3. There is only 1, and this 0 is also significant, so there are 3. So the least significant figure in the raw data is actually 1. So you can write your answer in 1 or 1 more than least significant figure. So what you have to do is you have to find acceleration and you have to find resultant force acting on the object and give both of your answers in appropriate significant figure. So you'll be using the normal equation for the acceleration, which is u minus t by t. Just plugging in all the values, you got this answer. Now, as the least significant figure is 1, so you can give your answer in 1 or 2 significant figure. So 5.25 is having 3 sig fig. So what I'm going to do is I'm going to round that off to 2 sig fig, which is 5.3 meter per second. In the similar way, forces MA, so you just multiply them and you got this answer. Again, you have to write your answer in like 2 or 3 sig fig. So the better answer is 3 sig fig, which is 13.1 Newton. Okay, the last example, which you will solve yourself. This is a cylinder and its radius is 25, base area, like radius of base is 25 cm and height is 50 cm. So you have to find mass of the water in it, provided the density of water is 1010 kilogram per meter cube. You have to find volume of cylinder, you have to find mass of water, and you have to express your answer in appropriate significant figure. So you have to try this question yourself. And just giving you the idea about it, you have to use density is mass over volume, and volume is mass over density, right? This is the thing that you have to use. And no, not for the, this is actually for the first one, not this equation. The appropriate equation is volume equal pi r square into h. So just fill in all the values over here, 0.25 square and 0.5. So you will get the value of the volume, and that is like quite easy because this is simply a straightforward question of volume measurement, and which is 0.098. 0.098. So you can write it 0.1 meter cube. Okay, now similarly, if you want to measure the mass, for the mass, what you can do is, it is like density is mass over volume, and from here mass is density into volume. So the density is like 1010 and volume is 0.1. When you multiply them, it is 101 kilogram. So that is it. What I'm going to do is I'm going to share a worksheet with all of you. So that worksheet would be related to the estimations and the significant figure. So this was the video lecture number 1 for this series. We're done with this, and very soon I'm going to share the link of the other video lectures. Take care, everyone. Have a nice day.